Understanding Part B of the building regulations is an important part of any construction professional's job in designing for fire safety. A major revamp of the regs came into force last year, but getting to grips with new approved Document B accompanying the regs is easier said than done. For a start, it's twice the size of the previous edition. It includes major changes to the compliance criteria and greater technical detail. And it's published in two parts to cover domestic and non-domestic buildings. In this programme, we'll be talking about the changes relating to residential and non-residential buildings, and we'll be drawing some conclusions as to the effectiveness of the new approved Document B.
And joining us in the studio to try to simplify things for us is Miller Hanna from Hoare Lee Fire. Welcome to the studio, Miller. First of all, the whole approach to fire safety engineering is evolving, really, isn't it? What's happened now? What way is it different from the historical approach?
Well, interestingly, in the UK, we've always had an approach of disaster-led regulations. So we have a disaster, we introduce a piece of legislation, and that can be traced all the way back to the Great Fire of London, where we had the fire and we introduced legislation to make buildings further apart and make them stone. And since 1985, we've tried to be a bit more pragmatic and holistic and look at fire engineering, look at the total package, forget about disasters and look at what are the risks that people are actually subjected to.
And approved Document B has now been in force for a year now, hasn't it? How's it working in practice?
The new approved Document B has been in action for the year. It's working well. There has been a number of grey areas which are starting to be flushed out, and there's good opportunities for industry to look at the grey areas and how things can actually improve.
As a fire engineer, what are the challenges on producing and coming up with a holistic fire strategy?
Communication. It's really all to do with the information that you're given. It's understanding what the client actually wants to build, how they want to operate it, and how they want to manage that building. So if you get good information at the beginning, it's much easier to actually direct them to a good solution.
OK, well, let's take a look at approved Document B now and examine the first major area of change.
Well, the first big area of change is that residential buildings over 30 metres in height are now required to have sprinklers. In the design process, reference may be made to BS 9251 and BS 5306 Part 2. There is the potential that additional floor height and additional riser space will be needed. Also, 2 risers will be required where a building is over 45 metres in height.
Tell us first of all about UK flat design and why it's considered important now to have sprinklers.
Well, after the war there was a study called Post-War Building Studies, and it looked at all different types of buildings, and it looked at giving recommendations. Now, if you and I were neighbours in a flat complex, well, if you were to have a fire, you would have a detector in your flat that would activate, and that would warn you, and you would leave the building. I would sit there happily, unaware totally that there was a fire in the building, until the fire brigade arrived and knocked on my door. So that is called a defend-in-place strategy. Now, as modern design was actually pushing the boundaries and making flat design taller and taller, we had a single stair actually serving those flats. And it was really felt that the higher we went, we were starting to actually push the boundaries maybe a little bit too far. And we needed to bring in an extra factor of safety, and that factor of safety was considered to be sprinklers.
But of course there's a cost implication, which is what, for your average size apartment? What are the implications?
Well, the cost really depends on the specification, but typically you'll be looking at £1,000 to £2,000 per a normal size flat, which when you put it in context of, let's say, the white goods of that flat, it's actually quite similar. Not a huge cost, but a cost.
And what does BS 9251 say in terms of design guidance?
Well, this was actually quite a good move. BS 9251 actually looked at reducing the standard of the sprinklers that you would have in a typical office. So it looked at using more innovative materials such as plastic. It looked at reducing the amount of water that would be effectively squirted out of the sprinkler to make it more manageable, to make it more cost effective, and therefore it's actually being adopted quite well.
But of course there are design implications, aren't there, in terms of the space required for risers, plant space and so on. Roof height, how does that take into account?
Well, indeed. I mean, that's one of the things that's often forgotten about, is that if you were designing a building that didn't have sprinklers, it would have a certain floor-to-ceiling height. When you start introducing sprinklers and air conditioning and other factors, it can edge the floor-to-ceiling heights up, which can have an effect on the overall building. But one of the encouraging things in the past year, when this has been in place, is the fact that industry's really taken this on board and actually coming up with some really innovative designs for sprinkler systems, environmentally looking at taking it off of rainwater harvesting, also maybe looking at more sort of what we would call a mist system. So instead of having a traditional sprinkler, which is a bit like your power shower at home.
Right, just a mist that spreads out.
Exactly, so it's much finer particles, much less water space. So the industry have done well, I think.
What about buildings that are over 45 metres high?
Well, here we have a problem in that the amount of pressure that we require. So we actually sometimes have to have 2 risers. But once again, industry have been looking at that, saying, well, we have to get the person water to flush the toilet. Can we somehow take the sprinklers off that water? And therefore we can double up in the risers. So I think the industry's been very innovative with this.
As long as they're not going to the toilet at the same time, I suppose. But
Indeed so. Indeed so.
I mean, all these fire precautions coming in. Is there any concession on other measures if there's so much protection coming in?
This is my biggest disappointment, actually. Whenever you introduce new regulations, the government have to actually look at a cost-benefit analysis. They have to say, we're introducing sprinklers, it's going to save X number of lives, save property, etc., and it's cost-effective to do this. The government introduced sprinklers, decided it was cost-effective, but didn't really give industry anything back. It effectively said, give us the sprinklers, and we're not going to give you anything back. Now, for me, when I watch a TV programme such as Friends or Frasier, and they come into their flat, and they open the flat door and they've got their wonderful view, that is called open plan design. In the UK, you tend to design your flat that you open a very heavy fire door, and you have another corridor full of heavy fire doors, so it takes a long time before you see your view. And I think that's quite restrictive design.
So what sort of concessions could have been made there? There's one, I suppose.
That's one concession, because in this other countries such as America, which has residential sprinklers, they would allow open plan design. Other concessions would have been nice to have a reduction in the ventilation to the common corridors. It would have been nice to have a reduction to the fire resistance required. So there are a lot of things that government could have done to actually make it more palatable for industry, but they chose not to.
All right. Well, the requirements for sprinklers isn't the only thing that's changed in residential design.
No, other changes in residential design first relate to common corridor ventilation. Vents to the outside now have to be 1.5 metres squared. Smoke shafts are now included in the guidance and should have closed bases, with a number of restrictions on the design. Also, door closers are no longer required to internal protected halls of residential flats. Locks and child stays are permitted for escape windows. Fire service access is now required to within 45 metres of all areas, and multi-storey flats may have a single means of escape, provided an enhanced smoke detection system is incorporated.
OK, let's take a look first of all then at the requirements for changes to outside vents. What are they?
If you take a step back to the post-war building studies that I mentioned earlier, they looked at actually a traditional design in a residential apartment building would be to have a window to outside, and that size would be 1.5 metres squared in area. Now, you might be sitting there thinking, that's very scientific. If it only were true. That was really a guesstimate. It was a number to say, let's have a vent of this size.
As simple as that?
Very much so. And what... Obviously, a modern developer doesn't want his facade to be taken up with common corridor. he wants that facade to be bedrooms that he can actually then sell on. And industry were starting to move to bringing that vent internal into what we would term a smoke shaft. And the big difference in this new code is to actually say smoke shafts are good. They actually work quite well. Previously, when you had a window and you had a very tall building, the wind effects could overpower that vent. Now, when you're bringing everything internal and you're having the shaft, you actually have a much safer design.
And the design requirements for smoke shafts have changed as well?
Indeed. The government spent a lot of money with the Building Research Establishment on a study of, effectively, smoke shafts. And they came up with a number of rules in terms of the size, so it should be 1.5 again, but it should have a minimum dimension of 0.85. Certain design guidelines in terms of at roof level. It has to be a certain height, it has to avoid wind effects, because the last thing you want is the smoke trying to come up a shaft and the wind coming along, coming down the shaft. The wind tends to win.
Yes. Another change. I mean, closers, automatic closers on internal doors in protected halls, yes, in flats, no longer required.
Indeed. This is one that I personally don't sign up to. As I described before, when you enter your flat door, you come into your corridor, and these doors that would lead onto your bedroom typically, previously would have door closers. Now, we all know that when people come into their flats, the first thing they do is take the door closers off, or they wedge them open. And the government took the opinion that, well, if people are actually bypassing them, why provide them? And obviously, one of their other concerns with little children's fingers, the door closer can slam with quite an effect. And if the little kids' fingers were there, they felt a couple of problems.
OK, so one change there.
Yes.
But also, let me ask you about fire service access, because the requirements there, again, that's moved on.
It's a very subtle change, but has dramatic effects. Previously, when the fireman turned up to an apartment building, he would expect to get his hose out, drag it up the stairs, and within 45 metres he would get to the flat entrance door. The government felt that that was maybe a little bit too tight, and now are asking for the 45 metres to go all the way past the flat door into the apartment.
To the far end of the flat?
Exactly.
Right.
Which actually has quite an impact, because now we're looking at bringing dry risers into the stair core to take that distance of the stair out of the calculation just to reach the flat point.
Which is becoming necessary. What about a single means of escape in multi-storey flats, where there is a smoke detection system?
This is what we would call a duplex apartment. So you come into your apartment and you have a downstairs and an upstairs, typically your bedrooms on the upstairs. The old approved document B would require that from that upper level you had an escape route away from your lower level. And now it's quite cumbersome to design, and it's not really what occupants wanted. The government looked at what was happening in industry, and they decided that if you have more detection, so instead of having one detector in the flat, you had a detector in every room, it was in fact, it's probably better than a two-storey house. So I think that's quite a positive change.
So that requirement went?
Yes.
OK, well, that's the residential side of things. Let's move on now to non-residential buildings.
The changes in approved document B relating to non-residential buildings cover phased evacuation in buildings bigger than 45 metres in height, warehouse compartment size, firefighting shafts, void consideration and private fire hydrants.
Well, let's talk now about phased evacuation, because there is now a requirement to consider firefighting activities, isn't there? What's the implications of that?
This all stems from the 9/11 events, and afterwards the government set up a group, Building Disaster Advisory Group, to look at what lessons could we learn from these events. And I'm sure everybody will have seen the documentaries where, as the evacuation is occurring and people are coming downstairs,
the firefighters are going up.
Exactly, and you're two opposing flows, which was very difficult. And the conclusion was that really we should give the fire service more access to these buildings, particularly where the evacuation is delayed in terms of phased. Phased evacuation is typically used in the City of London in the very tall high-rise offices. And it seemed quite a simple thing to say.
And the advantages and disadvantages of that are what?
Well, the advantages are all for the fire service, really, in that they have more chance of getting to the fire floor quickly and actually trying to put the fire out. The disadvantage is for the developer. It means wider stairs in the best instance, and if you only have a tower with 2 stairs, it could, in some cases, ask for a 3rd stair.
We are talking here about buildings over 45 metres.
Indeed, so they're quite high-rise buildings.
What about when you're designing for warehouse-size buildings?
In the UK, there used to be what I would term a postcode lottery. So if you were designing a warehouse in Greater Manchester, there was a local act that would say any warehouse over a certain size, which was 7,000 metres cubed, requires sprinklers. If you went a mile along and went into Cheshire, there was no local act, so you could have the exact same warehouse. It could be 1 mile long by 1 mile wide with no sprinklers. The government felt, first of all, it was unfair to have discrepancies nationally. And secondly, we're also concerned with the size of these warehouses. Anybody who's driven up the M1 will see some of the warehouses just to the side, which are actually very, very tall, contain a lot of fire load. And they felt that just to actually bring it into a national standard was a wise thing.
Overall, what's changed in terms of fire service access?
Well, interestingly, the government took firefighting shafts out of storage buildings, as we've just discussed, and actually said, well, assembly and recreational buildings are more of a risk for firefighters, and we should introduce firefighting shafts to these types of buildings, such as theatres, schools, etc. So that's probably the main change.
What about buildings where there is, say, an atrium, a large building, might be a school, might be one of these, the new schools being built now?
Indeed. The schools currently being built, the current academies, which are some fantastic designs, all want open voids and atria to make the space much more interesting and much more vibrant. Previously, we would not treat that as an atrium because we wouldn't say it penetrated a compartment floor, and we would allow balcony escape and with extra detection. What the government have introduced is to say, well, you can't actually escape within 4.5 metres of the balcony edge. And if you do escape within that distance, you now have to prove that it's acceptable. So a lot of those academy designs would really struggle under the new regulations.
Interesting. I was just wondering how this has really evolved and moved on in terms of schools. I was talking to a chief fire officer a little while ago who was saying that sprinklers have got to be put into schools because of, A, the danger to his officers, but also the amount of schoolwork, coursework, that just literally goes up in smoke in seconds. Is thinking moving on here?
Thinking is moving on. You have to take a step back and realise that the regulations are there for life safety, and nobody has really died in a school fire. But you bring an interesting point in terms of property protection.
Because typically, of course, this is arson at night, very often.
Indeed. Fires in schools are very commonplace. And I think a lot of people, such as the insurers, such as Zurich, and the regulations are starting to say, well, there could be a very good case for sprinklers, and you're now starting to find in the schools that we're designing, I would say at least half of them are now starting to introduce sprinklers.
Interesting. Private fire hydrants. This whole area, this looks like being very expensive for clients, doesn't it?
Indeed so. Up until the approved document B, the provision of fire hydrants actually lay in responsibility with the fire service. And the government wanted to change this. They wanted to say, well, if you're the developer and you're building a warehouse there, really you should ensure that there's water for the fire service. And the government, in their cost-benefit analysis, said, well, it'll be cost neutral because everybody's doing it already and it doesn't really cost that much. But what they forgot to factor in is that if you're building that warehouse in the middle of nowhere and the water supply is actually quite poor, you have to start putting in tanks and pumps and the pipe work. And I think one of our clients actually, when doing this, actually cost £250,000. So
because the amount of water that could potentially be required.
And
so there is a big cost.
Indeed so. There was no infrastructure around their site. So.
All right, well, plenty to digest there. Let us just summarise now what we've heard today.
Starting with changes to residential buildings. The first big change is that sprinklers are now required to be incorporated into buildings greater than 30 metres high. There's a number of changes relating to the ventilation of common corridors. Door closers to protected hallways are no longer required. And fire service access to all areas is a must. Moving on to non-residential buildings. Phased evacuation in buildings greater than 45 metres in height has to be considered. There's a number of issues to consider in respect of warehouse compartment size. Likewise with the design of firefighting shafts. And the design of voids, such as atria. And finally, the provision of private fire hydrants, previously the responsibility of the fire service, which now becomes the responsibility of the developer under the building regulations.
So, Miller, what does this mean overall in terms of the designer's overall approach when they're looking at fire safety?
I think the first thing they really should look at is that get fire safety advice at the very earliest stages of projects. These changes do have some significant impacts. If you find out about it very early, you can do something about it. You can look at how you can change the design of the building to incorporate the changes with very little impact. If you find them after planning, or you find them when you're really committed to a shape and a design, they can be very expensive to fit into the building afterwards. So it's very simple things. If your building's over 30 metres, you know you're going to have to provide sprinklers. You're not going to negotiate your way out of it. If you're looking at a school and you want a big open void, this can be done, but you really need to sit and think about it at the beginning. How can you plan the escape routes? How can you actually provide additional protection? That may be sprinklers, it may be smoke ventilation. There's a lot of things you can do, but if you think about it early enough, you've got a chance.
So think about it early, talk to the experts, make sure you know what you've got to do. That's the key.
Indeed.
And then as we look ahead, how do you see things developing in terms of fire safety in the future?
I think there'll be a lot more fire engineering, a lot more performance-based code. So instead of saying, thou shall provide sprinklers over 30 metres, more of what we would call functional and performance-based design, which is please make sure that people can get out of the building, rather than actually being this prescriptive guidance.
And the need, therefore, to prove that that's possible.
Indeed.
Well, thank you. That is all we have time for today. So many thanks to Miller for joining us today. More in the study notes from him, but from all of us in the studio, goodbye.